All right. It may be a mistake, but let's go in blind for one more. Find the index of the first occurrence in a string. I'm finding that honestly, even though they're easy, medium, and hard, but the easy kind of has its own kind of trick to it because just because it's easy doesn't mean that you'll well even though it's easy to get the right answer, it's really hard to get an answer that beats people's run times. It's kind of like you're playing golf and there's like par threes, par fours, and par fives. And like, sure, like the hard problems are hard. Like it's hard to get, to like get the answer on a hard problem. But like, as long as you get there, usually you'll score all right. For the easy problems, there's always a faster way to do it, it seems. But I'm learning a lot as a result, so I'm glad I'm doing this. Given two strings, needle and haystack, return the index of the first occurrence of needle in haystack, or -1 if needle is not in haystack. Okay. So this actually is giving me some questions about how equality works with strings because I'm wondering if I actually don't think that'll make a difference. It's very small, but I'm wondering if I can save any time by having it compare individual characters rather than entire strings. Why don't I do this the simplest way and then see if that's a good runtime? And then if it's not a good runtime, I'll try to do it better. Yeah, makes sense. Okay. Let's just do for I in range. So we're going to iterate through the string up to, we're going to iterate through the haystack character by character. But we had to make sure to not go too far. And the way we're going to do that is by doing range length of this minus the length of this. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. Then -3 would be 5. We actually want 6, so maybe it'd be minus needle plus 1. Yeah. Okay, we'll just do that, see what happens. I was about to type out plus. My brain is not working. And then we just want to get a range. So I wonder if it saves any time to like store the length in a variable. I really don't think it does because it's such, it's not like you're accessing a big portion of data. But we're gonna say like needle size. So we're gonna say, okay, now we're just gonna use splicing or slicing. We're gonna use haystack from, I hope this is inclusive, exclusive. So if haystack from I to I plus needle length equals needle, return I. And then if we go through that and don't find anything, then we just return -1. Would that work first try? That would actually be kind of cool. Yeah, I don't think so. Oh, yeah, of course. What am I thinking? It's not the whole string, it's the length of them. Oh, that's cool. Yeah, okay. It worked. Let's see how fast it works. Okay, that's good enough for me. Especially because the memory's good. Who would applauded me? Yeah, I don't really need to do any better there. But yeah, cool. So we just go through the needle and the haystack. Okay, yeah, to go over that one more time, we store the needle in a variable because we use it twice, the needle length. Then we just iterate through the string. We check if that string matches, well, we check if the string matches, well, from starting at that index plus the length of the needle equals the needle. Yeah. And then my reason was like, yeah, you could maybe try to make it faster by like eliminating unnecessary checks. Like if the word you just checked was like nothing close to the needle, then like iterating through once more is not going to help. But for code this small, it's really hard to get it to work that to like make it work much faster, I think, because for every for every iteration you try to eliminate, I feel like you add another like condition. I don't know. It's a damned if you do, damned if you don't. I don't know. I could be stupid, but I'm sick. I'm allowed to be. Um, yeah. All right. Love you very much. See you later.